Pete's Jeep tours. It's $150 per passenger, and they give you the total amount collected and the probability. The first thing they do is ask you to make a histogram. By now, we already know how to do it. Then they ask you to find the mean and interpret this value in context. So as we know, we enter that in L1 and L2, and if you were to go ahead and calculate that, we get our expected value to equal and more importantly, what does that mean in context? It means that per day, Pete is going to bring in $562.50. That's just the expected amount he's going to go ahead and make. Find the variance. Well, your calculator actually goes ahead and gives you a variance, and they give you a variance of 26,718.75 cents. So it's saying that our data could be pretty spread out here. We're going to look more at the standard deviation, and to find the standard deviation is you just need to go ahead and take the square root, and that's going to give you 163.46. And what that means in the context of the problem is the amount he makes daily is going to vary by about $163.46 from the mean. The last part of this talks about describing the shape of the graph. The shape of the graph, it's one peak, or I guess you could call it unimodal. It looks approximately normal. Yeah, I wouldn't say it's really skewed any way dramatically. Let's take a look at Pete again. We have to figure in that it costs Pete money for like gas, ferry passes for each trip. So what happens is his profit's not actually $300. It's 300 minus the 100, so his profit is 200. So his profit's actually getting cut down for all of that. So instead of making $450, you got to factor in that permit. So that's $350. His probabilities don't change. Instead of making 600, it's now 500 because we need to subtract 100 off of it. And here's our new probability distribution. The histogram, I'm going to leave that up to you guys to do. Everything's just going to go down a little bit. What's the expected value of the mean? Well, if you remember from our rules, this was one of our rules there. All we have to do is if we're subtracting 100 off of it, our original mean from the problem was 562.50. And all I'm doing is subtracting $100 off of it. Then I could literally just take 100 $100 off of it because everything is being shifted by the same amount. And since everything is being shifted in the same amount, that means our variance and our standard deviation remains the same as the last problem.